Let's take a chance to dive in and see how we can actually improve the performance of a live site. So this is a site that I've worked with a lot, the Hedonmeter website, and what this is showing is the average happiness on Twitter over the last 18 months. So a bunch of things to observe here, but let's just focus on analyzing the performance. So if we want to do that, we're going to use the network profiler and the timeline debugger in particular. So to do that, let's go ahead and open up the JavaScript console. And let's see what we got. All right, so let's see, elements, console. Here we are. We failed to load the fave icon, which is just the little icon up here. And what else do we got? Okay, we can see what things were loaded. In particular, we're interested in recording what happened while the page loaded. So let's go ahead and start recording and then perform an action on the site. So let's see what we can do here. We can hover, and that's going to bring up these small shifts. So why don't we go ahead and analyze that in particular. So we'll do hover, and then if you go ahead and click on one of these, it'll open up a bigger shift. There's a lot more things we could dive into to analyze the performance of, like some of these toggles and loading other days, or even the performance of the embed tool. But let's just focus to start. We'll go ahead and do a hover, and then open up one of the bigger word shift graphs and see what we can find. So if we go ahead and begin recording, sorry, we're going to record the performance. Let's see what we got. Let's go back to the page, and let's hover on Christmas Day, and let's see what we got here. Loading the full shift. Okay, so it looks like it worked, and let's go see what we got. Recorded 16 seconds of material here. And we got a whole bunch of stuff. So what this shows on the timeline is the page itself. So there we got the hover, and there it loaded up and opened the shift. So we can see this by just scrolling across the top. And we can also see what types of things on this graph were actually doing the work. So a lot of rendering to draw this big shift, which is the purple, and of course a lot of loading for all these things. Here looks like scripting took the main part of getting this to pop up. And so we can go ahead and let's dive in on these particular events. So let's look at where we popped up the small shift. So let's see, that happened back here. So we can zoom in and we can see what interactions happened. So we can look here, we have a mouse move. Right, so when the hover went over that circle, that's when we got the mouse move object. So let's focus in on that. Looks like it happened here, right? And we can go ahead and see what actually happened. So the mouse move, and we can see what is actually fired. So here's the mouse move event that got called. Let's zoom in a little bit here. Right, and see what we got. So this is going to give us the full function stack of what got called for this particular call. And what it actually runs is a callback that will go ahead and load the data and get that and make that small shift. So if we dive in here, we can go ahead and see what this event itself called. So if we go into the call tree, we can see what actually got called here. Called on content.js. And if we run from the bottom, right, it's sometimes it's a little harder to find where your actual code ran. So let's see, we are here, and the shift popped up over here. So it actually looks like we were a little early. So let's see, that load actually happened here. Yeah, so this actually, our code actually got fired down here, which is why we couldn't find it. So this is actually fired indexall.js at line 1600. So this is the main script where everything's concatenated together, and we can see what happened here. So this main script called an anonymous function, so we don't get the name of that function, and ultimately it called a function called draw small shift. So draw small shift actually goes ahead and generates that. You can see mostly what it does is rendering. And so if we dive in, you see it's doing the D3 stuff here, doing an append, setting the attributes on D3, all of this from the selection. And it does that for a while, and looks like a lot of what it does is doing this split width method, which calls string.width. So this is one of the performance bottlenecks that I'm reasonably aware of, but most of what this function spends its time doing, or a good amount, is computing the width of strings. So when you see the hover on the page, right, it has to know how wide the string is going to be to know how far to scale these bars. So it'll actually go ahead and compute the width of the first 5 strings, and then know how to scale it. So it looks like a lot of that computation is actually just figuring out the widths of those strings. So that is a function that takes a while, and then it goes and makes actually a asynchronous load. XHR is the XML HTTP response method, which goes ahead and loads data. And we can also at the same time see which files are getting loaded. So here is the main shift file from hedonimeter.org. Right, so here we were able to go in and find that this string.width is what really slowed us down. So if we were to move to only the top 1 or 2, that would slow it down. And of course, we're only using 5 because I probably tried to do the string width on all the strings, but of course that would be much too slow, considering that doing only 5 of them took up 10 milliseconds. So you could easily make a very slow animation by using some of these functions inappropriately. And we can also dive in and look at when we loaded up the main shift, and we're going to find something similar because it also calls that main method. There's a lot more that happens here. It loads a number of different files, and then it has to manage those files individually. But you can see that again, one of the main things that it's doing is doing the string.width. Here's the replot method, which went ahead and did the replot where it moved the circles around. And again, these are spending a lot of time computing string widths. So if we want to make this act really fast, we could go ahead and just approximate the string width. That's all we have for now. If we had any other maybe performance bottlenecks, we'd be able to go in and find out what's going on with them in the site, and we can continue to analyze to make this performance as snappy as possible.